Good morning, everyone. I'm Yash, Doshi. I'm from CEPT University, and my title of this project is Early Detection of Climate Impact on Crop Production. As we know that India is a vast country with billions of populations, so we need that much of agriculture production to sustain this much big country. So, like as per because of the climate change, there may be increase of 6 to 10% of crop yield by 2050, which will result to 5 to 7% of increase in crop price. So, according to World Bank, the agriculture accounts more than 25% gives the proportion of more than 25% to GDP. And agriculture growth is affected by like urban sprawl, population growth, water demand, and climate change. So, as per the UNO, United Nations Food and Security, it is said that the value of agriculture production in India depend between 100 to 200 to 50 billions in 2016. As we know that amount of production required in India is very large. These are the different crops as well as food products which will be in the highest demand uh, for now. The aim of this research is to estimate the impact of early season rainfall, the effect on crop yield. The objectives are visualizing the rainfall trend in India from 2005 to 2019. They are analyzing the effect of crop covariates on crop yield and to develop a model, a machine learning model to predict the effect of crop yield due to rainfall variability of first 30 days of the crop season. So as you know, there are the in India there are three type of crop like Kharif, Rabi, and Zaid which depends on different month a month of sowing and month of harvesting and different type of crop which grows in that particular period. So, as we know that, the main motive of this project is as the 60% of farmland in India is identified and resulting to the high volatility in yield, which also has many impacted state region of India. So it is said that if we can get the trace back of deviation from the normal in the very early stage of the monsoon, so we can as per that deviation we can change the crop yield and we can increase the crop production. So this is the different agroecological regions in India. So my study area is all India. Main component of agriculture is like topography, like type of soil, soil resources, water resources, and length of growing period of crops, as well as the climate factors, soil properties, and physiographic settings. There are many different there are different 20 agroecological regions. India has been divided into 20 different agroecological regions. So these are the number of data sets which were used, like rainfall data set, onset monsoon rates, cost of cultivation data set, which is the product level data collected through surveys by state and central government. Temperature data set, soil moisture or soil organic matter, work density, pH value, and cation exchange capacity. So, starting with the literature studies of agriculture scenarios, natural agriculture scenarios, overview of crops and Indian monsoon. Then we study formulated the aim and objective. After then, the data collection was done in spatial data and non-spatial data. The spatial data includes state boundaries, like administrative boundaries, temperature data set, and soil data set, which was collected from Google Earth Engine. The non-spatial data set includes weather report from Indian Meteorological Department, rainfall data set from 2005 to 2022, and cost of cultivation data set which is provided from Minister of Agriculture. And this all were after this the geodatabase was made and the analysis was done. Also, model builder tool was made which can be used to automated the process. As we know that number of rainfall days and dry and wet years also impact the crop yield. As we know, because of scarcity of water supply, a rainy year on the other hand is one of if there is more precipitation or rainfall or from the usual, there will be increasing crop yield. But if the rainfall is less, it can impact the crop yield. So here, the number of rainy days of each year has been calculated, and the number of dry and wet years for from 2005 to 2020 for each state of India has been calculated. This map shows the visualization of rainfall variability across the India from 2005 to 2020, and we can see that in most of the years the rainfall has been less than its normal is normal, and only in 2019 the rainfall was higher than its normal value. So in only in 2019 the amount of rainfall was more, which which is good for crop yield. And also the rainfall variation among each region, like India has been divided into north, south, east and west region. Also it was calculated. This is the motif detection, which is a library in Python. Using the stump library in Python, it was calculated, which shows the the time series analysis of from the time series analysis of rainfall. It shows the similar pattern across the data set. So we can see that how similar the rainfall pattern were occurred in among this year. So after this, the we can see that changes in crop yield. It is for year 2006 and 2020. The 2006 is the lowest, as from the graph we can see that 2006 is the lowest year where for the crop yield, and in 2019 was the highest year where the crop yield was there. Also from the chart we can see from the rainfall and temperature comparing to the yield chart we can see that if the rainfall is decrease if the rainfall and temperature is decreasing, there has been a decrease in the crop yield. So both the rainfall and temperature are the important parameter for the crop yield. And this chart shows the state-wise distribution of crop yield, in which we can see that Maharashtra, Tamil Nadu, Uttar Pradesh, and West Andhra Pradesh are the state where the crop yield was highest for among this year. A simple convolution neural network was implemented on the dataset, which consists around 1200 columns and 6000 rows, which has rainfall and temperature for 15 years, cost of cultivation dataset for 15 years, soil parameters like soil pH value, soil pressure action capacity, rock density, soil organic content, as well as soil moisture. This is the model architecture. There are some model parameters which is some model parameters like number of input layers, number of hidden layer, number of nodes, activation function, base size, learning rate, and iterations. There was 83% of accuracy in this model. The model predict the intensity if the intensity is changing from low to high, then in that particular villages there will be more more likely to defect in crop yield because of these parameters. So for this model implementation, the result was compared from the highlighted areas. Some of the villages were taken, and it was seen that if the rainfall was early, 10 to 15 days early from the time, then there was increasing crop yield. Same if the rainfall was late for 10 to 15 or 5 to 15 days, there was gradually decrease in crop yield. So this study shows that the trend in changes in rainfall pattern from 2005 to 2020 over the India, and it was seen that only in 2019 there was higher rainfall. Rest all the year has been in negative, which affect the agriculture.
The number of rainy days as well as dry years also was calculated, which impact on agriculture, and a strong correlation between rainfall, temperature, and yield was seen. Then, major crop like bajra, wheat, and jowar as their own impact on rainfall. Some has the higher impact on rainfall, where some has no significant change because of this parameter, as well as this conversion model letter was implemented, which was good in identifying the geographical and temporal pattern in dataset, which was used with the accuracy of 83%. Though because the accuracy was 83%, this model was over predicting specific class value. The This model will help predict how early and late onset impact the crop yield. These are the limitation of this study. Thank you.